Hello students, this is the help video for slides number 12 and 13 of the Unit 2 project for physics, the drop project. So let's go ahead and take a look at this slide. This slide we're taking a look at talking about the final velocity of your object before it hits the ground. Now in order to do this, you're going to use any non-breakable object in order to drop as long as it drops similar to your object, right? So if you have an egg, obviously you shouldn't use a feather. A feather will not drop in the same way as an egg, but you could use a tennis ball. Okay, so for this part of your project, please make sure if you are doing the extra credit version, do not use your breakable object yet. All right, so in this case, you should only use a non-breakable object for this part because you obviously don't want to break your object before you get to the experiment. All right, so please use any non-breakable object that's similar to your object in size and weight. So I recommend just using a ball instead in order to calculate the final velocity of what your egg's velocity will be before it hits the ground. But again, don't actually use your egg, use something else. If you're doing the non-extra credit version, just use any of your objects, all right? Keep in mind that for you, if you're doing the non-extra credit version, you do need to start it from the correct starting height, which your options for starting height were 100 centimeters, 40 inches, or 100 finger widths. Again, if you're not familiar with that, you need to go back to the previous instructional videos so that you know what I'm talking about. Okay, so what you're going to go ahead and do is you're going to use your phone or a stopwatch, so use your phone stopwatch or a real stopwatch to time how long it takes for a non-breakable object to hit the ground from your chosen drop height. So for your extra credit version, if you're doing this version, drop it from where you plan on dropping your egg or water balloon or whatever you're breaking or trying not to break. And if you're doing the non-extra credit version, again, from the starting height that was provided here for you. Okay, so you're going to drop it from that height, and then what you're going to go ahead and do is you are going to calculate how fast it is moving before it hits the ground based on this time that you measured. So what you'll go ahead and do is you're going to go ahead and think about we have this equation right here where final velocity equals initial velocity plus the acceleration due to gravity times time. So some things we need to know are the initial velocity, the acceleration due to gravity, and the time. So initial velocity, if the object is dropped from rest, you shouldn't be throwing it or anything, you're just letting it go. So in this case, it should be starting off at 0 meters per second. So that should be true for everyone. Feel free to copy that. Everybody should be starting from 0. Now also, the acceleration due to gravity should be negative 9.8 meters per second. And that should be true for everybody because we're all on Earth. All right, so we're all dropping from Earth on Earth, so we should all have the acceleration due to gravity. Now your time will be different, all right? So for the time, this is the time that you measured with your phone or stopwatch. I will tell you that your time will probably be less than a second, all right? So you'll probably have 0 point something something seconds, okay? If you have more than a second, it should still be close to a single second depending on how high you're dropping it from. If you're dropping it from like a 4th story, then you might get closer to having more than a second. But really, for most of you, it should be less than a second if you're just like standing on a chair. So if you have like 50 seconds and that's how long it took to measure, that's insane. So that's wrong. Okay, so make sure that your answer is around a second, less than a second. If you're dropping from really high, it might be more than a second, but still it should be pretty close. Okay, then you're going to go ahead and calculate your final velocity. So you're going to plug in your initial velocity, which we said we started from rest, so that should be 0. You'll plug in your acceleration due to gravity, which we said should be negative 9.8, and then you'll plug in your time. All right, so whatever time you measured here goes into this last blank. Remember that you do need to calculate first anything in parentheses, so you'll do negative 9.8 times your time, and you should end up with a negative answer, right? So that's why this negative is still here with your answer. We still have a 0 here. And so then just adding 0 plus whatever this answer is going to be identical. So this right here should actually be the same as whatever this number is because adding 0 to it doesn't change it. So that should be your final velocity there. Okay, so that will help you with question number 12. We do need the correct final velocity in order to do question number 13. If slide number 12 is wrong, then question 13 will also be wrong. So the question is, what is the momentum of your single object using its mass? Again, from the project mass slide, which was up here, so slide number 8. All right, and its final velocity, which was from the final velocity that we just calculated on slide 12. All right, so what you'll go ahead and do is you're going to go ahead and enter your kilograms of your mass. Again, for most of your objects are probably small. So again, it should be less than a kilogram. Remember, a kilogram is the same as 2.2 pounds. So most of you are not dealing with objects that are more than 2.2 pounds, so you shouldn't have more than a kilogram. There are some things that might be heavier, like if you're using a bowling ball might be like 5 kilograms. But again, if you have a huge number for this, it's wrong. Okay, so please make sure you have the right number of kilograms, that on the project slide for number 8, you watched the video and you converted to kilograms. All right, so taking a look here, for example, you can have your large egg, so 0.057 kilograms. And so that's what you would plug in here. And then your final velocity is your answer that you got on the final velocity slide, this answer right here, your negative velocity right there. All right, so plugging that in, you should be able to plug those two things in and then calculate them, okay? Based on the equation, what are two ways to increase the momentum of your object? Remember that either of these can be increased, right? So think about what is this variable and what is this variable. If you increase either of those variables, it will increase the momentum. So you should have two answers because there are two variables. Explain what you need to increase. Increase what is this variable, or increase what is this variable. All right, and that should help you figure out how to increase momentum. Remember, momentum is just how hard it is to stop an object. So think about, what do we need to do? What do we need to do to an object to make it harder to stop? And again, this is related to the two variables in the equation. Okay, so let me go ahead and just move that over here. All right, so it's related to these two variables right here. What does M stand for? What does V stand for? All right, so that should help you figure out this question right here. And then you should be good to go ahead and move on to anything else you need to work on. Thanks, everyone.